In this video, we're going to talk about the average rate of change. And this is a kind of pre-calculus or algebra concept, and then we're going to lead into the calculus thing in the next video. So the average rate of change of a function describes the constant change that would need to occur in order to move between the two inputs. So if we're talking about rates of change, a lot of times we're always going to talk about like driving a car or moving. So if I think about being in my car, and I start at point A and I drive my car to point B, let's just say, to make the numbers kind of easy, let's just say this is 60 miles. Then I'm able to do that in 60 minutes. How fast am I going on average? All right, well, the distance equals rate times time. I figure how fast I'm going to divide rate equals distance over time. All right, so I went 60 miles in time. We're doing miles per hour, not miles per minute, so it's 1 hour, and that's 60 miles per hour. All right, that's just the average rate, so I could have been going really fast at the start and hit traffic and kind of stopped and then gone really fast again. But that's the average speed I was going throughout this time. All right, so that's the basic idea of average rate of change. If I went just 60 the whole time, it'd be the same if I went 100 sometimes, 20 the other times, and kind of average out to 60. That's the average value. And the formula for a function looks like this. So you take the output at B minus the output at A, and then divide it by the inputs B and A. As an example, let's find the average rate of change of this function, y equals 3x minus 1, from x equals 1 to x equals 3. Think about our formula. All right, we need to figure out what f of b is, so that's 3. It doesn't really matter which one you call a and b, but we'll do the second one is b, and the first one's a. So f of 3 means I'm going to plug in 3 in for my x. And for that, I get 8. So the top here, this is going to be 8. And then for f of 1, that's when I put in 1 for x, and I get 2. That's 6 over 2, which equals 3. So the average change of this function from 1 to 3 is 3. Again, the function might go up really quickly at some points and slower at other points, but on average, it's changing at a rate of 3. And there's no units here, so it could be like 3 miles per hour, 3 kilometers per minute, that type of thing. All right, so the unit is 3. All right, here we're looking at a graph. We're trying to find the average rate of change from 3 to 7. So first we look at where's our graph at 3? It's right here. And where's our graph at 7? It's right there. So if we do the same thing, and we do our average rate of change is f of b minus f of a over b minus a. All right, so our values are 7 and 3, so I'll just rewrite it with 7 and 3. What is f of 7? F of 7 is I put 7 into my function and I get out the y value. So in this case, f of 7 is 3. It's that y value is associated with that dot. And then f of 3 is 1 because it's that y value. All right, and 3 minus 1 is 2. 7 minus 3 is 4. And that's 1/2. All right, so again, let's talk about what that average rate of change actually means. It means that's how much my function changes on average each step. So if I go from 3 over to 4, my function should change by 1/2. So it should go up to there. So that should be the next point. Then from there, I go over and I change by 1/2, and now I'm here. Do it again. Over, up 1/2. Oops. And last time, over, up 1/2. And you can see I reach that other point. So on average, if I just have this constant 1/2 change every single time, then I get to the other point. And one other thing you might notice, if you look at these dots, these red and green dots, they actually form a straight line. And then this 1/2 represents how far left and right I've gone and how far up and down I've gone. So in this case, I've gone up 0.5 and over 1. That simplifies to 1/2. So this is actually the slope of this yellow line. All right, and that's the most important thing from this video to know, is that when we're talking about average rate of change, it's actually a slope if we're talking about a graph. And it turns out the average rate of change is the slope of what we call the secant line. So if I have some graph I'm going to find the average rate of change between these 2 points. The secant line is the line that connects them. So I'll just connect these points with a line. And the slope of that line is the average rate of change. All right, so that's the kind of starting to get into the calc type of stuff that you might not know this from pre-calc, but it turns out the average rate of change is the slope of this line that connects the 2 points. All right, so here's the important stuff from this lesson. All right, average rate of change is a constant value, just how much I would have to change on average to get to that endpoint. And then the average rate of change is equal to the slope of the secant line. So slope we know is that rise over run stuff. And secant line means you're connecting 2 points.